After completing PhD from IIT Bombay, Dr. Kodgire worked as a postdoc fellow at CSM, Kodgire, USA. Prior joining as a former head of Department of Chemical Engineering at PDPU, he has more than 16 years of teaching and research experience. He has taught various chemical engineering courses to UG and PG level students. His research focus is biofuels, energy and environment. He has published a good number of research articles in peer-reviewed international journals. Recently applied few of patents as well. Currently, he is supervising 2 research scholars for doctoral work and guided more than 20 PG students in the area of energy and environment research area. Apart from this, having been conferred with research award and fellowships, Dr. Kodgire is carrying out various consultancies, research projects worth almost 5 crore rupees, where the fundamentals and applications of chemical and energy engineering are focused. Sir, thank you for being with us. I request Dr. Kodgire sir to start his presentations.
Thank you, sir, for your warm introduction to the August gathering present today. And I hope definitely these last 5 days might be very enthralling to the participants, getting to know about the very important aspect of today's situation in terms of whenever we talk about anything about energy or whenever we talk anything about the environment, these are the close to heart topics. And fortunately, these are the interdisciplinary areas basically. So not only chemical, but even mechanical, civil engineers, to an extent, electrical engineer people are used and involved to whatever the extent they are possible to contribute into this field. So just give me a couple of minutes so that I can just share my presentation. There seems to be some. Just wait, sir. The system is taking us some time. So let me just quit and just relog in, sir. Just it is giving some problem. I hope now the screen is visible to all.
Yes, sir. Yes, sir.
Perfectly fine. So again, as I said, thank you and welcome. Hope this is now properly full screen is visible, sir.
Not sir. Please press F5.
Okay, I made it F5. Is it now visible?
Full screen is not visible, sir.
Okay.
Just go in the slideshow.
Yeah, I have done that slideshow. I have done share screen also. Let me again just stop the screen sharing and then let me, because many times this is the big problem we face. We do the rehearsal, bit of rehearsal, but last moment it happens something that it gets stuck up some point. Now is it
It's
better?
okay. Yeah, it's better. Okay, fine.
Now it is full screen, sir.
Not full screen, but fine. It is visible. I think we should start.
Okay. So again, thank you, sir, for inviting me to give a talk on to the STTP on advances in waste management system. And I already mentioned that the topics, whether it is concerning to the environment related or whether it is concerning to the energy related, these are the vital areas of concern for today. May it be the youngsters who are getting their degrees in BTech or PG programs, or may it be the researchers to find out the solution to the problems which we have faced since the maybe you can say lack of certain understanding or lack of certain things which could have happened to lead to us today's situation. So before taking to the actual talk, so let me just introduce me. Some of you are definitely aware about the background. At the same time, I would like to just know all of the some new attendees. Myself belong to the Pandit Deendayal Petroleum University. This is our aerial view of the campus. We have four different schools: petroleum management, liberal studies, School of Technology. So I belong to the part of School of Technology in Chemical Department, and we have a flagship program of petroleum technology. Apart from that, we have several center of excellences, may it be the solar, may it be then automation, may it be the incubation and entrepreneurship, or biofuel, biointer studies, which for which also I am associated with. Then there are certainly cement center of excellence, so and so forth, which some of you are aware but not aware. Then they are directly involved with the study of the in-house students as well as training of the students from the outside the university at Gujarat state level or the international, at the uh, uh, national level. So this will be my overall flow of the presentation. So being this topic, we are going to discuss is a wastewater management.
Sir, your slide is not changing. Will you please change your slide?
Yeah, it is changing on my end. So I don't know why it is not changing.
Yes, now it has changed. Now it has
Now it
changed.
has changed. So
Yes.
on which slide you are watching the, it is on the
Flow,
second
flow.
slide.
Third slide.
Okay, probably
Yes,
there
fine.
might be
Yes,
some
fine.
delay in the transmission probably, sir. So I think we need to just keep on reminding me in between so I can
Yes, sir.
just open up my presentation. So as I said, this is my broad outline of the presentation. Being this is a wastewater management, so I need to touch upon some basic topics also. To the fresh students, those who are experienced, probably for them it is just recap or revision of some of the concepts. Then certain challenges and how to take care about those challenges. Because when we talk about the management, I'll try to discuss those things in well depth and detail so that even the newcomers, those who are probably not having much background, will get the feel and idea about this particular area. Because as I heard, most of the times mechanical department people will not have a exclusive course in depth, I'm saying, the way chemical or civil engineering people, but I have tried to take into account the varied background of the audience probably available on the platform. So let's me look into the certain basic fundamental things. uh, we are all fascinated with such a beautiful region of a nature, and that's always soothing. And of course, since our cultural aspects and heritage, we have given due respect and importance to the nature. And when we talk about nature or universe as such, of course, nature universe is a bit different, but I'm putting that in a holistic perspective as such. It is comprised of the five main ingredients that's we call as a Panch Mahabhut: earth, ether, fire, air, and water. And amongst them, what today we are focusing is the water. Of course, the other component of water we are, and we all are aware since the beginning of the universe, what is the importance of water. We are all aware since through the scriptures or through the other studies and as a engineering and technological studies. Let's look into how it is interrelated and how certain things are basically important. What I'm putting here is why this water and today's topic is much apt in terms of discussion with some basic fundamental and other understandings. As I said, water is integrated with ecosystem, human settlements. Of course, when you talk about the usage of the water by the society at large, so then it generates the waste as well. So we need to treat that waste as a part of sanitation. Of course, again, water is much important to energy generation. We all know the electricity we get from the power
Sorry to
plant.
interrupt, sir, but your slide is not changing again. It's on stuck on outline of talk.
Okay, so let me put
Yes,
now.
now it's now it's visible.
I think I'll not put the full screen, but I'll try to put it in this particular mode
Yeah.
because I think there is some problem. If I'm changing, it is not changing. Or let me unshare and then once again try to share it.
No issue, sir. It's fine. It's visible now.
Okay. So I was talking about, I was just discussing about the very beautiful nature and its ingredient as a five basic elements which we pursue through the scriptures as well as other ingredients, and then the Akash, Vayu, Agni, Jal, and Prithvi. These things we are much familiar, and out of which we are today going to discuss bit out water and its importance as such through the wastewater management. Why that wastewater management today is important, although we are aware since childhood and since ancient age point of view that water is a very important ingredient, and many of the habitats which we see, they are situated where the water bodies are as such available. So let's take you to the other perspective that this water has a very good interaction when you talk about the human beings, human settlements, or the ecosystem and the agriculture to produce the energy for the different grades of the human beings or animals, or to produce the energy. They are all interlinked, and which you can see on the one circle where all the things interrelated and they are all associated with the water. This particular thing one talks about the particular thing that is global issues and problems, how water is directly and indirectly related to some of the points which I'm just putting on this particular slide. This is a particular era or the year, except we all know before pandemic, I'm just speaking about, not after pandemic, the CO2 level was the highest in 8 lakh years, last 8 lakh years, which is almost about 420 ppm of the CO2 in the atmosphere, and which is a consequence of the concern of environmental pollution and to an extent to the water pollution as well. Although water pollution in different sense we are basically going to focus, but global warming, the average rise in temperature, CO2 concentration, these are certain challenges with which water is equally associated and water is going to get affected. Some other aspects, and at the bottom at the right corner you are seeing the country wise. Probably I'm unfortunately not able to make it full screen, so bear me on that particular part. Uh, so this particular thing, when we talk about water, this particular scenario is very familiar with you all. Since our school days, we see this type of schematics where this talks about the water cycle, how we get water. I'm not going to get into more details as such, but just want to recap. we get the water by evaporation, then condensation, then cloud formation, condensation, and then it falls on the higher altitudes, then it runs off, and then surface water, groundwater, number of different sources, aquifers, lakes, oceans, number of things are basically there. What you see here is the different parts and different components in terms of quantities are given. So there are certain things which talks about the contribution of different areas, may it be biological water, may it be fresh water, their percentage in our ecosystem or in our universe, deep ocean water and all, see their fractions is there. So that is the major source. We look into really, when we talk about so much water is available, is that available for our consumption? Okay. After that, this is a water fluxes in terms of the what is get into soil, crops, or the human beings, we are utilizing it for the aggregation or irrigation point of view. Then the blue arrows will talk about the consumptive water by the agriculture, industry, and domestic, which is going to be a major part of our subsequent discussion. And the gray water, which is a now new concept. So far, the fresh water and the wastewater was the concept. These days, because of the enormous growth in terms of population and their demands and requirement, a new type of waste which is being basically generated, typically in the urban areas, that is called grey water. So where mostly the kitchen waste, most of your bathroom waste, toilet waste, and all those things are basically getting taken into account. Here also you'll see certain numbers which are projected that talks about their quantum. Say the flux is expressed in terms of the area 10 to the power 3 kilometer cube in terms of that much region of the entire globe, and per that much area, how much these different fractions of green, blue, and gray water are being utilized or produced. And as I said, some of that blue component is of more importance to us, that blue arrows, which are these two components basically. So having said that, and having seen into the current crisis, which I already elaborated in the previous slides, which are all integrated, there is no exclusive thing that water has only exclusive part and problem and it has independent with the other problems. There are a number of problems, and typically in 2014, the world has churned out certain thought process at United Nations meetings, and they have come up with sustainable development growth. And many of us, many of the youngsters, they might have studied a particular course, that is environmental science. The need of introducing that environmental science was the same thing what the problems I cited in the previous one. But again, while citing these sustainable goal problems, there are 17 statements which they have given: no poverty, no hunger, green, good health, quality education, gender equality, so on and so forth, food, good life, good water. And this particular one with pink circle, what is being highlighted, again is of more concern. With increasing population, with increasing industrialization, with increasing demands and usage, which I say whimsical usage of available water, the water scarcity is happening. At the same time, water is getting consumed and it is converted into waste basically. And that is the reason of concern for today. And this particular aspect, the youngsters should basically keep in mind. That is ultimate goal. When we have to set that this is a goal, that means there is some problem which is going on into the system. That's why we have to focus what was available, what we are using, still it is in crisis. And that crisis slowly we'll discuss in terms of the wastewater, how it is basically contributing to get this particular problem. Again, as I said, in continuation with that, what I specified in the previous slide, that is sustainable goal statement 6, that is securing sustainable water for all. And shortly, I'll come to a particular problem, why I am focusing on that particular part so much and so forth. So we are aware what for the water is needed. In again subsequent slide, we'll look into more in detail. But these are the all different components of the sustainable water: maintain quality, maintain the water governance, maintain the resources, and the water-related disasters to be minimized. Otherwise, if we talk about only water pollution, water waste, and all these things, the health-related issues going to come. That again, as I said, in subsequent slides, I'll talk about. But prior to that, just look into the when we talk about the availability of water, just look, I spoke about the water cycle and plenty of water is available. But we are all aware there is only 3% of fresh water is available across the globe, which we consider as a fresh or drinkable water. Just imagine, out of plenty of water, only 3%. And another alarming thing is, out of this 3%, 2.5% water is in the form of the glaciers. Now here a small fraction you see on the top, whatever the 2.5 or 3% fraction of this which I am just talking in terms of cubic kilometer cube, it is talks about almost 35 lakhs cubic kilometer cube is the water quantum. What I talk about the entire globe's 3% fresh water, and out of which 2.5 is the 67 or 70% of that is glaciers, and groundwater, remaining water, the 5% is left out, of which 30% is groundwater, and ice and permeable water is of 86%. And that's how, just imagine and just understand, that much is only a precious thing which is available with us for all human beings as well as the ecosystem. When we talk about, apart from human beings, there are trees, creatures, animals, and all things for their well-being. Just to again give some numbers through rainfall and other ground sources which are available as a surface water and the underground water, this much a billion cubic meter water is as such being available, but some is in stored form, something is in running form, and something that is what basically we are utilizing. As I said, most of the water when we talk about goes in the irrigation, and that is one of the big sector when we talk about water management as such, or in terms of controlling waste management, how this is important sector which we will discuss. At the same time, two other components, that is domestic and industrial power plants. Power plants are the another important sectors where the water consumption is there. And again, these are the major sources for wastewater to be generated. That is domestic and industrial activities. Because irrigation and agriculture, a lot of water gets absorbed in water, and then energy source through the crops and other energy sources we basically get, or to the drinkable water point of view. But domestic and industrial power plant sources are the major concerns. This again just give you the youngsters the snapshot, global scenario, and the water component which is utilized by the different sectors. Again, I say beg pardon of you because certain letters are very small and I probably not able to make it a full screen. Is it displayed as a full screen, sir, or is it displayed as a part of my PPT slides?
It is displayed as a part of your slides, sir, not full screen, sir.
It is not full screen, am I right?
Yes, sir. Yes, sir.
So again, just let me try to make it clear. Now is it little better, full screen?
No, sir, it is still not full screen, but it's fine, sir. We can see the trends.
Okay. So what I'm just little elaborate is the left-hand graph talks about the water withdrawal. I already said water may be groundwater or surface water, whether it is fresh or unfresh, whatever it may be. But if you see United States tops in terms of the water withdrawal, the scale on the left-hand graph is meter cubes basically. So US tops almost with 1200 as a meter cube withdrawal in terms of the per capita consumption is concerned. Now this is per capita is throughout the year, not for per day. Followed by Greece, Canada, Turkey, so on and so forth. Although on this particular graph, our India is not shown because as such per capita consumption of water maybe per day or per year is relatively less compared to the certain advanced countries. On the right hand side of the small bar chart, what you see is the x-axis is a market value in terms of percentage, and first is when we talk about the water and whatever the most of the water which is available, that is basically available as a waste water treatment in terms of that utilized water what is available for in the market share. And that's the reason this particular system or area is of much importance, that quantum of work and quantum of new knowledge is required to make that water useful. That's where the theme is, that wastewater management. Followed by that, industrial wastewater treatment, then water which is come out or utilized for the infrastructure, but then which is used for the industrial applications, maybe pumps, filtration, so on and so forth, or engineering consultancy and so on and so forth. These are, but major, the top 2-3 areas are of much importance for us to go ahead and talk about. Apart from global, just look at it to the Indian scenario. This talks about the most of the sewage which is generated across the different states of India. So we are just trying to come down, and we are all aware about the geographic location. And if you see Gujarat being close to the coastal area, Maharashtra again to be near to the coastal area, West Bengal, where most of the industrial activities are there, and they are basically contributing to the generation of sewage. When I say sewage, I'm talking about the domestic waste generated, as well as to an extent the industrial waste which is basically generated. So large quantum of activities are basically generated, and that needs to be basically taken care. We cannot just discard them off as it is. And apart from that, apart from, as I mentioned, domestic and industrial aspects, so here there are certain other things which I just talked about. The water we get, here something is being talked about the domestic front, where we use water and that activity generates the wastewater. So maybe morning showering or brushing the teeth, or getting ourselves fresh or clean in terms of bathroom, toilets, washing the dishes after consuming food, and cleaning the things, as well as cleaning the household materials. And if you see at the bottom, it talks about the percentage. Generally in India, we presume while doing any calculations, civil students might be much familiar, or the faculties, that water demand, that's what we generally teach and study, and out of which the different activities we need to take into account. And to take care of the activity for a person, we need to then set aside a particular volume of water in terms of liters. So in India, typically we talk about 150 liters per day. Now that depends from the maybe metros will be little more, rural areas might be little less, but average is a 150 liter per day per capita consumption of water, and that percentage share for the different activities basically is shown. So except, and most of these activities basically generate the wastewater. Industrial activity will look into later, and all these are again the point of concern as well as need to be understood. This particular slide talks about the waste use efficiency. Now this particular aspect towards end will elaborate more, but again, if you see the surface water in terms of billion meter cube is being given the numbers, or groundwater irrigation, which I have shown earlier, but this is talking about the Indian context, not from the global context point of view. Then urban drinking water, how much water we are withdrawing from the available resources, or rural drinking, and industrial usage, or some other usage, miscellaneous usage. Now these bottom, there are bar charts with blue and red colors are there. So red color talks about the scope of improvement, and that is another important aspect. Later on, little bit we'll discuss at the towards the end. And blue one is the something which is presently available in terms of efficiencies, how efficiently we are using. Out of the total one, there is an entire scope of the areas where we can implement the management concepts, which later on we'll discuss as a part of our further topics basically. So this basically talks about water use efficiency, which is of important to understand at this particular stage. Okay. So moving ahead, I was just talking about that the global problems, and then certain issues, all the different sources are available, so on and so forth. But the current situation, and I spoke you about the United Nations sustainable goal for the different aspects of the life for betterment of the society. Really, there is a water crisis available? Yes. Whatever the population we have, today we have almost 730 crore population, and out of which 1 billion people, or almost 100 crore peoples, are lack of having the good access to the water. Okay. then two out of three people living with the water shortage by 2025. Forget about that. Just few days back, I was reading one of the reports. It talks about there are geographical locations which are identified which are water scare, and among that acute water scare. Some of the examples are just cited in the same slide. So there is increasing demand and decline in the fresh water. We all are aware as a part of global warming, climate change, the monsoon cycle have disrupted. In the very few slides I showed about the water cycle, which is under the ideal condition, but that ideal condition is not persisted. So the water which is to be obtained as a natural source is declining through the rain or through the monsoon, so on and so forth. So some of the crisis is Ahmedabad. Before lockdown, there was a study represented in Times of India that because of urbanization and Ahmedabad being identified as one of the upcoming metro city, the lot of urbanization is happening and a lot of high-rises buildings are being there, and most of the water withdrawal is from the underground systems. And I already mentioned previous slides, 150 liter is the average consumption, but the water withdrawal is happening at the rate of 230 to 250 liters per capita per day. Just imagine. And with that rate, if we are withdrawing the water available, then Ahmedabad city, I'm just giving one location, there are several other locations, will not have any water available for any of the activities. So there will be another example is again just before the lockdown and previous December 2019 or so, the Chennai crisis. Some of the pictures will soon see in the next slide, as well as globally. Of course, South Africa itself is identified as a acute water crisis region, and Cape Town was hardly having any water, where the mayor of the Cape Town was supposed to announce that if the citizens are not judiciously utilizing water, then the Cape Town in another 1 month time period will not have any water for any activity. Just these are very recent examples which I'm just talking about, and that gives you an idea why today's topic, it is not we are focusing on only water, but as I said, the water which is consumed for the domestic activity and industrial activities. If there is no water, then there will be no domestic activity, there will be no industrial activity from which the waste is generated, and that waste needs to be produced. But even we cannot shut down our economic growth, and these the reasons both domestic and industrial activity needs to be happening. And if we don't take care of the water, there are adverse effects, which I had spoke about the environmental concerns in the previous slides, which is affecting the water available. At the same time, that poor water when we use for domestic front as well as the industrial front is adding the water treatment burden, as well as then water which is generated, that will also create a additional financial as well as financial liability on individuals as well as the commercial aspects. More or less, as I said, if we will not take care of these things, if the scarcity persists, then there will be water wars. There will be not nation wars for the geographical demographic authority, claiming the demographic authority, but for kind of say water war. Just to give an idea a little bit, some of the youngsters might have seen one of the recent Bond movies, maybe not immediately recently released, but one before. There, the one of the problem was the water, which was the major concern of the global war or something, water war basically. Just it was a theme and fictitious thing, but that going to be a reality in the next future, near future. So with that, let me see you or take you as a connection with the water crisis. What is the problem which you are basically facing? Okay. Probably for that, I need to make me a slideshow because there are some animations I put. Is it now a full screen, or is it again a part of my slides only, sir?
Sir, it is not a full screen yet.
Okay, because there are some animations or some. So let me again just continue for a couple of minutes. I'll just try to make unshare and try to share, because that will be very helpful to me and make it more further more interesting to the just pardon me all the students for a while. I'll again stop sharing to share my screen. Only I don't know whether there is a network issue at my end or some other problems. I'm not able to. Now, is it a full screen?
No, sir, it is still not full screen.
So it's not again full screen yet.
No, not yet, sir.
Not again, because it is showing me full screen at my end. I don't know about your end. What about the
No, sir.
other or other audience? Can they just chat and just can you get the feedback? What more they are observing? Whether they are
Yes, sir.
observing.
Yes.
No, the students or the participants are also observing as a part of the slides or part of the full screen.
No, sir, it's a parts of slide, not full screen.
Okay. Okay, just so that will be now a little better. So this is what I was just talking about, and I spoke about the current crisis and current scenarios. That there is a acute water droughts are foresighted. Some regions are getting already droughts. The Chennai crisis, which I showed, or there will be kind of situation at the right top bottom, which is being shown, or the water which is been getting dirtier and that water is being utilized by a major. So there are plenty of complex problems which are basically integrated in this case. And that is the reason we need to focus on an important aspect, that is the wastewater management. Because as I said, although I need to, as I said, give an importance where from the source of wastewater is coming, that is the water, and we have seen the so far the scope and importance of the different activities where the water preserving and water maintenance is important. So let's look into the three aspects, different aspects. Waste, how it is basically defined. Generally, it is called any material or substance or which is eliminated by different activities, may it be human or may it be domestic activity. So material or substance or byproduct eliminated or discarded and which is of no longer use, that is generally called as a waste. What is management? Management is to forecast and plan to organize or to command or coordinate or to control the different activities. Just I mentioned, foresighting, the population is going to increase, urbanization is going to happen. So I need to foresee and plan. Yes, my people require, my new industries require water requirement, and that utility or those activity will generate water. So I need to plan even for the wastewater activities and wastewater management plans. So that all. And wastewater basically again talks about is the process involved in dealing with the waste of the human and organisms, including its minimization, handling, processing, storage, recycle, transport, and finally dispose of. That is what is basically wastewater management. When I say that, what I am trying to talk about here is it involves technical understanding of the activities and processes, at the same time the managerial concepts and managerial activities which needs to be taken care in order to control the problem. And that's what I said here. It involves the minimization, handling, processing, how effectively I handle, how effectively I can store it, how effectively I can recycle back, so that the problems which are cited cannot or either can be minimized or can be eliminated from the system. So there are certain aspects always goes when we generate the waste. It can be centralized or decentralized. So centralized is generally the domestic activities and the decentralized is the on-site treatment, which is mostly the industrial activity or the small-scale businesses and all those things. So about choices, whether you have to centrally treat or decentralize and treat that water anyway, the management concept has to be brought into picture. We have to, with the problems which I cited, acute water crises and management, we need to be open to implement the treatment options, may it be centralized or may it be the decentralized one. Ultimately, any of the treatment or management concept is to reduce the pollutant levels so that water, if wanted to be discarded, will be easily discarded with the current statutory norms which are led by the government and statutory bodies, or if it is to be utilized or reused, then it should be properly utilized, where the activities, when I say activity, may it be process, may it be human consumption, or may it be irrigation or agriculture activities, they will not get hampered. That is the major objective of the waste management. Again, here, one thing we need to understand, although I said centralized and decentralized, important aspect to be understood is the treatment and disposal of industrial waste water is bit different than domestic wastewater. What is important is in the domestic wastewater treatment, the activities across the geographical location, urban or rural, the activities are very common and very similar. So you focus what others are doing in terms of the analysis of other system is done rather than the waste streams consideration under your consideration. So what I'm just talking about is being the activities are common, and if you see when the students and the expert, they will be agree with the fact that the ETP plants, domestic ETP treatment plants, they are very synchronized and the activities are very normal or very straightforward and standard procedures are there. However, it is not same with the industry, and why? There are several category of industries, may it be mechanical oriented, electrical oriented, chemical oriented, organic, pharma, paint, pigment, fertilizer, you name, paper, and plenty of these things are there where no two industries are same. Within the same category of industries, the industrial activities or the focus of the industry is totally different. That we'll study and discuss little bit in the some of the examples when we discuss in the subsequent slides. So this particular important aspect one has to understand. Ultimately, both the aspect needs to be focused, but one finer difference is there that youngsters needs to be understood here. So as I said, industrial water is a byproduct of industrial activity. Municipal is most of the household activities, small businesses, which we discussed previously. And as I said, both the treatment where the technical component comes as well and engineering component comes and management component are either cases essential. So let's again here there was a kind of a animation and probably I'm not able to show it to you, so I need to just get rid of some of the animations which I put. So generally when we talk about the waste sources and types, there are four broad waste types, and what we are focusing is the industrial or the municipal waste, although I have not put highlighted here arrow, but these two waste we are focusing. And amongst them, the major one where when you talk about the industrial waste, domestic, as we have already seen, the household activities, washing, draining, bathroom waste, so on and so forth, that basically generates the domestic waste. Industrial waste basically from the manufacturing activities as well as the utility waste, which is used, like mostly the cooling water or the steam which is generated or the cold water which is being discarded after utilization, as well as the sanitary uses after the waste generated by the sanitary uses across the industries. The different kitchenwares will be there, kitchen activities will be there, human beings are using bathrooms, toilets and all this. Through those activities, that fraction is generally very small, but these are the broad classification of the industrial waste basically. Now, when we talk about that, we need to again get a quick glimpse, which as I said, many of you are aware, but I want to highlight some of these things because that is where later on the engineering and technological kind of say revolutions and the technological more insight is basically needed, and much of research is basically going on those areas. Suspended solids, they need to be taken care. It will create the sludge deposition, and anaerobic conditions will create a problem for the waste treatment as well as aquatic environment. nutrients, like, because a lot of different products may be industrial activities or the household products which we are consuming, which ultimately contains the phosphorus, nitrogen, and carbon-based elements. I'm talking in the complex nature. Later on, they will create a problem for their easy removal from the waste resources, and that's how they will create a problem. Another problem which these nutrients will create is the formation of the undesirable aquatic life. That is, they will create a algae formation or deposition at the bottom, and they are not easily disintegrated basically. Another priority pollutants like organic and inorganic components, typically they are carcinogenic or toxic in nature. If they are present in the wastewater, that will create another big problem. Then refractory organic materials like surfactants, the phenolic materials or pesticides which are run off through the agricultural activities or the production activities, they are of big concern which cannot be easily treated. Then there are a lot of electronics items being circulated in the market, and computers, mobiles, the solar panel based materials, electronics or satellite based materials, so on and so forth. Those making those items, you need to utilize, as well as even some petrochemical and organic chemical industries activities. We are using some heavy metals. We'll quickly look into that. What are the different heavy metals? When I talk about that, maybe fluorine, arsenic, lead, then vanadium or platinum. These are the different heavy metals. Mercury are being discarded as a part of the wastewater streams, and again they are the harmful one, as well as sometimes the dissolved inorganics like the hardness bearing materials, calcium, sodium, magnesium, so on and so forth. These are the important contaminants, and they needs to be taken care. That is where the technology and their wastewater management basically is very important. So when we again talk about the industrial wastewater, these are again some important and very known facts, but I would like to quickly run through these things. The wastewater, what is obtained, will have physical characteristics, chemical characteristics, and biological characteristics. When we talk about the technological aspect or engineering aspect, some of these parameters will be important, which we'll again discuss in the subsequent slide. So when we talk about physical parameters or physical properties, total solids, odor, color, temperature, turbidity, because in end usage point of view, some of these physical properties are important, especially color and turbidity in terms of aesthetic of water. Again, this is useful whether it is a fresh water which is used or a retreated water to be used for the other applications. That aesthetic perspective point of view, these physical parameters are very important. Chemical parameters, mostly organic matters, that is the fat, oil, grease, or the volatile organic components, or some of the refractory pollutants. I talk about phenol, surfactants. These are the chemical waste, which is our chemical characteristics which are present into the wastewater. And based on that, there are two important parameters which very essentially has to be defined for the any waste, whether it is domestic or whether it is a industrial waste. That is a biological oxygen demand and chemical oxygen demand. What is biological oxygen demand? This is the organic matter which can be consumed or which can be decomposed by the microorganisms which are utilized for the treatment of that wastewater. Or these microorganisms, in short, simple words we can say, can easily decompose the different pollutants which I discussed in the previous slide. And what is chemical oxygen demand? It is the oxygen required in the chemical transformation by the usage of the chemical reagents in order to disintegrate or in order to decompose the different pollutants which we have discussed, may it be organic, may it be colloidal, may it be oil-based, grease-based, fertilizer, phenolic, or heavy metal-based. They need to be disintegrated and made into a simple, less harmful byproducts. That's for chemical agents are required, and in that process, whatever the oxygen is required, that talks about the chemical oxygen demand. These are the two essential and important parameters. And apart from that, among the physical parameter, the total suspended solids, that is a crucial parameter which we'll discuss in the subsequent slide. And overall wastewater management or re-usage point of view, which is another important concept of wastewater management, is the water which is been reused should not have any pathogenic organisms. Typically, the water, if we are discarding from the slaughterhouses or from the organic industries, they may contain some molds or fungi, which are or starch or yeast. They are not useful beyond certain concentration. So they needs to be taken care, and there are certain advanced techniques which we'll discuss later on as a quick review. They needs to be removed. So these three basic parameters to be taken care basically. So as I said, when you talk about industrial water, these important parameters needs to be taken care. Biodegradability, where I talked about BOD and COD, how much quantity of this BOD and COD is there in terms of their numbers, how much volume, that is in terms of meter cube, in terms of liter cube, and so on and so forth. That is very essential. How much it's the variation, because when you talk about the domestic as well as industrial activity, there are three different parameters. One is the minimum, one is the average term, and there is a maximum term. Under which circumstances there is a minimum load of waste generation is there, under which load maximum waste generation is there, whether your activities are continuous or they are interrupting, or in terms of like say semi-continuous or batch processes, whether they are frequently occurring or occurring over a large durations of time span. So these are the different aspects basically focuses or kind of say needed to be considered in order to take care about the quality and quantity of the wastewater. When that is where the wastewater needs to be basically characterized. And out of that, two parameters, that is BOD and COD, of very importance, that the difference between COD and BOD values would provide an indication of the quality and the relative sense, that is whether it is can be degradable easily by only microorganisms, or whether you need to use the different chemical oxidants in order to degrade the or in order to treat the water. So there are certain thumb rules. We'll just speak that about that also. So ratio of COD to BOD, if it is less than 3, then it is a good water in terms of taking treatment through the biological treatment or secondary treatment. That again we'll discuss little later. If it is more than 3, and that is the reason you need to analyze what I spoke about, the different parameters, physical, chemical, or biological. They needs to be analyzed, and many of you are aware about the waste treatment kind of say activities. Daily 3 times these different parameters are being evaluated, and based on that certain activities are controlled or managed dynamically. So ETP operations are basically dynamic. They are not straightforward that you put certain parameters and you need to go to sleep and the work is been done. No, it is not like that. So there are some industries which are of very concern where the BOD and COD ratio is very high, that we'll discuss. So first parameter, to give a glimpse. Now I talk about that within the similar industries, the water which is generated as waste is not of same quality or same activity. Here there are 6 different cases. The 5 cases of are different categories. I'll not get into too many details, but one thing is that these are the slaughterhouse, and there are different, the product which is obtained is goes to the different activities, and based on that the different parameters which are mentioned, maybe the flow rate, maybe the COD BOD value, total suspended solids, or oil and grease, or the total gel nitrogen content, and all this is our ammonical nitrogen. Different parameters are there. What as a part of biodegradability we have to focus is the 5 cases, case 1, 2, 3, 4, and 6. If you see, the BOD to COD ratio is less than 3. So for a thumb rule or technical understanding, these type of waste can be easily treated by the biological treatment processes. However, case 5 is not normal like the 5 other cases. Why? Because case 5 BOD to COD to BOD ratio is more than 3. It is 3.3 to 4. So this particular water has the activities which contains maybe the traces of blood, and that's how the water is getting complex. It cannot be easily disintegrated by the normal ways what we do for the other 5 cases. So some additional waste management concepts needs to be incorporated so that the water can be easily treated. I'm just focusing here the importance of characteristics of wastewater needs to be focused on. Next example is the strength. So if you talk about the different industries, let's say again in the food industries or the organic industries, kind of say the sugar or food-based industries or agro industries, basically starch extraction or sugar milling or coconut streams. If you see the BOD to COD is drastically varying, and that's where the strength keeps on varying, which I have talked about, the domestic water variation, difference in domestic waste and industrial waste. So this also needs to be taken care, and that characterization is important. Another parameter is the volume. Now, this is a particular paper industry, and which is considered to be the largest industry or major industry where the plenty of water is used. Now, just imagine here, this is a almost 28,000 meter cube of water is required. That is on the average basis. I'm talking about the first case. And if it is the maximum production which is taking place, so almost 36,000 meter cube of water per day is required. Just imagine how many of domestic supply water tanks are basically required in the paper and pulp industries. So that's how you need to be aware, and these all parameters I'm just focusing and talking about. Based on that, on-site ETP plants needs to be designed, the volume, the treatment, the sizing of the equipment they need, and based on that, the different raw materials required for the different stages of the treatment is to be focused. That's the reason the effective characterization on regular basis is important. And variation of the flow parameters and certain parameters I just tried to put as a snapshot here, and it talks about the length and breadth of the industries made with the food process or vegetable processing, canned milk, pasteurizations, yogurt, industrial, school, or different sort of industries that is basically projected here. Now, look into I spoke about the specialty materials and which are heavy metals basically, or specialty chemicals, which needs to be basically bothered. And these are the certain things: the arsenic, cadmium, chrome, then the carbon itself, mercury, lead, nickel, zinc. There are many more, but the different industry sources which you'll talk about, the cross indicates these are the different heavy metals will be utilized in the systems for manufacturing of the products, and what are the waste is generated. You have to be for sure that these will be available in the waste to be treated, and accordingly a suitable thought process has to be gone into designing of the waste treatment plants and waste treatment management systems. So as I said earlier, I mentioned the production type, capacity, composition, makeup based on the physical and chemical characteristics, BOD, COD, TSS, so on and so forth. Whether the effluents can be segregated or not, those needs to be understood as a part of the treatment. The daily volume type, that's where the minimum, maximum, and average quantity, hourly basis or daily basis needs to be established. All these different statistics has to be available before planning or proper designing of the effluent treatment plant. Now, having this broad and brief idea, let's try to have a brief overview. Okay, we have done all the activities and you have generated the waste. What I need to be doing to take care of the waste? Now, this is something I am just putting from the students who are not at all having any idea of what is involved when we talk about the wastewater treatment plants means. So this gives a very brief and overall snapshot. That's what happens in any typical wastewater treatment plant. You get the waste, and first is the preliminary treatment. Then that waste goes for the primary treatment, then it goes for the secondary treatment, and then it goes for the tertiary treatment. These are the major stages in the waste treatment plant. So first is the removal of the bulk waste in terms of sticks, bags, rag, toilet paper, or tampons, and so on and so forth, which are easily observed to the eyes. That is what is done into the first stage, that is a pre-treatment or part of primary treatment. Then there are bars and screens, because this water comes through running from the lines and sometimes pipes and different clay, slit, or solid materials which are ranging from few centimeters to few millimeter scale. They are removed. Otherwise, if they are taken directly to the actual treatment, then they will create a problem. And that is where the grit chambers and sedimentation tanks as a part of primary treatment, these processes are there, where centimeter to millimeter scale and then millimeter to few micron scale particles are settled in this particular thing. When we do so, it takes care of 95% of total suspended solids in terms of the organic or inorganic in nature. And then comes the dissolved inorganic substances or organic substances which we are not able to taken care at the primary treatment are being taken care, where I spoke about the biological oxygen demand, chemical oxygen demand, and total suspended solid estimation of or the characteristic of this particular thing. So those ratios will take me on give me a thorough idea that okay, if the parameters are within limit, I can take and treat the water by means of utilizing the organisms. They will utilize these different organic pollutants available in the wastewater, consume them, disintegrate them into simple forms, maybe water, maybe some gases, and so on and so forth, which can be then subsequently separated, and my water can become useful for either discarded, or I can do a further treatment that water can be reused back into my system, or it can be thrown into the main water bodies for further usefulness. So that is where the tertiary treatments comes into picture, and you need to have a thorough analysis of the treatment characteristics or treatment, basically the characteristic of the waste. So this again further gives a little more elaborative aspect. Preliminary treatments talks about the screening, grinding, and these are the easy basically. And what involves is the equalization and oil separation is basically happening. Then when we talk about the primary, again there is a two types of activities. One is in chemical nature, where the chemical modification or treatment is being done by using of the different chemicals or by means of using the physical parameters. That is like not changing the phase, but by means of the sedimentation or filtration, the primary treatments are taking place. So when you talk about chemical methods, neutralization or coagulation and flocculation by use of flocculants or neutralizing agents, maybe acids or base are used to take care of the pollutants. When you talk about physical, whatever the chemical treatment sometimes we have done, or if the mass is having heavy weight, they can easily settle into the sedimentation tank, or whatever the flock is obtained, they can be separated. And then the water comes to the secondary treatment. Now, some of the arrows are not given in the first two treatments. They will just create some solid sludge which needs to be directly discarded. But from the physical statement, that is a flotation or sedimentation, they will create a sludge which is taken at the centralized stage. This primary treated water goes to the secondary treatment. Now there, when you talk about secondary treatment, these are the biological treatments where you are using microorganisms, and there are different configurations. So these microorganisms either can be fed into the bulk of water, or they are grown on certain substrates, and with those substrates the wastewater is brought in contact, or they are treated in absence or in presence of the oxygen, which is very much essential ingredient required for the microorganisms which are disintegrating the water. Based on that, activated sludge process, activated aerated lagoon process, trickling filter, anaerobic lagoons, or stabilization basins, these are the different activities. I will not go into the more details of technical details, but these are the broad activities or treatment falls under the secondary treatment. And then, as I said, based on whether the water quality parameters, the wastewater quality water which is obtained from these things is fall within the statutory requirement of the CPCB norms, GPCB norms, or the Ministry of Environment, what is been setting. If it is not happening, then there you have to take your water to the tertiary treatment. And these days, these tertiary treatments have become the integral part of the processes. What we pursued maybe 10 years back as an advancement, to an extent, a lot of again work and research is going on. Still, they are called as advanced treatments, but they are now becoming as a integral part of the process that we'll little later on discuss, and they plays very important role in wastewater management basically. So they involves the membrane-based techniques or adsorption or ion exchange methods, because what is today's mantra is we are not in a position to harm the environment. That stage is gone. If we still become ignorant and blind-eyed, then problem will come that the future generation will be bereft of anything. And that's what we discussed about the water crisis in the beginning. And in order to take care of whatever is available water and make it you usefully utilize for the different economic growth or for the sustainable society point of view, you need to go for these tertiary treatment activities. And there are certain biological parameters, maybe fungi or some other harmful bacteria and pathogens which are available. There is a chlorination, oxidation, or redox treatments are there. These are utilized for taking care of the water. Again, as I said, there are some important parameters at the bottom which are mentioned. What at each stage is taking care when you talk about the holistic view of a wastewater, or I can say here it is an advanced wastewater treatment plant schematic. And depending on the industry, some of these aspects are taken into account and some of the aspects are basically skipped from the process. Later on, the sludge which is obtained, that these days again there is a thorough talk which is going on, that is a waste to wealth. Nothing is called as a waste as such. From the waste or from the sludge also you can kind of say extract the valuable ingredients, and that will make an value addition to your organization or to your system to make you profitable and sustainable life point of view. So these overall aspects as a technical component are important. This is a little broader perspective of either domestic and undomestic, the collected or uncollected water goes to the untreated and treated, and then there is different sources are there. These are the, again, as I said, India is a very complex system, and not again as a part of report, as I said, in worldwide, almost only whatever the waste is generated, only 40% of the waste is properly treated. That's what I talk about the collected waste. Rest 60% is uncollected, or the industrialists, typically small scale industrialists or the small householding or the small domestic localities, they are not in a position to treat that water and they are directly discarding. So it is creating the soil pollution. Once the monsoon comes, from that soil water, the deposited pollutants are there. They are running off and they are merging into the lakes, oceans, rivers, so on and so forth. And these are the water bodies which are the source for the raw water. And they are again adding the load on the water treatment, and subsequently, that's what I just discussed previously, that it is increasing the load for the treatment either at the source or at the treatment level. So these aspects also needs to be properly understood, and that is where industrial wastewater management basically comes into picture. More or less, these aspects we have already discussed. Only few things what I just brought about, the different concepts goes. So there are certain operations may be primary, preliminary, secondary, or tertiary, can be classified into types of treatment. Some are the mechanical treatment, some are the biological treatment, and some are the chemical treatments. Just this distinction, these are some just as an general information or general knowledge point of view, some of the aspects need to be very well understood. So with again these understanding and what type of treatment goes into the system and certain thumb rules we discussed earlier or parameters we discussed, there is a acute need, and what waste management concepts and waste management treatments are going on, we'll quickly look into discuss those in the subsequent slides. So quantification, and as I already mentioned that we have to do parameter estimation, determination of characteristic of the process streams, BOD, COD, TDS, TSS, so on and so forth, and at the beginning itself identify whether the streams can be mixed or streams can be diluted. Likewise, these certain concepts has to be taken care, and to take care of these different things, there are certain thumb rules or certain parameters which are used into industry. That is the volume reduction. Just recall the parameters: biodegradability, strength, the variation, volume. So as a part of that, these are certain practices industries adopting. Now here, these you can call as a technological concepts, or where technology is involved, as well as managerial concepts. Like I'm saying, when I say managerial, applying a common sense or common logics and work out in a smart way. So classification of waste, depending on the industry type, first do the classification of waste. Try to go for the water conservation mechanisms and aspects, wherever you can go for it. The changing the production to decrease the waste. So some of the aspects we'll discuss in the subsequent slides, as well as a new concept which I talked about, centralized and decentralized concepts, that there are certain regions as identified as a water crisis region, and in those regions generally it is a concept that municipal waste is not utilized or industrial waste is not utilized. But the days are not far ahead that we need to think about judiciously to take care of or treat the both options, industrial as well as municipal waste, for making them reuse for the domestic. When I say domestic application, means for the drinking water purpose. And yes, today there are technological advancements are there. You will not make out any difference. If time allows, we'll show you some pictures that industrial waste which we cannot think about is being utilized, and we will not get an idea that water we are drinking as well. So these are certain volume reduction methods are adopted in the industries. Then waste strength reduction, that is process change, equipment modification, segregation of waste, equalization. Some of the things are a little bit overlapping, but we'll quickly look into some examples and that will give a more idea. So when we talk about, apart from that, there is another concept goes, is the one is a volume reduction, waste strength. Volume is the quantity, strength means the concentration, and all either of these things at the source itself, very first day or at the point where I'm making anything, that itself, what raw material I have to take, I have to use it judiciously, not very whimsically. So from that point of view, again, some redesigning of the product, facilities, durability, design, reuse concepts are there. So some of the outcomes or some of the important parameters, if you take care of the reuse, some concepts I have just put it here, that is the reduce the plant scrap by increasing the production efficiency. So equipments, what you are used, some in the subsequent slides, some other examples also will look little bit, that will give a more idea, as well as recover the plant materials such as solvents, scrap metals, plastics, paper, so on and so forth. So don't consider it as a waste. Try to build wealth from that waste. Return the package materials, pellets, and all these things. This doesn't directly related with the wastewater, but some of these practices of reuse and recycle, if you adopt, that will substantially reduce the load on the waste which is generated, and the easy treatment can be done and easy waste management can be done basically. So just to quickly look, process changes. One of the important industry, leather industry, is one which produces very toxic wastewater basically, and there are several stages which generates the waste. So some simple solutions. Earlier, people were used to use lime and sulfides to get rid of the skin from the dead animals, and then they were steatrate for the removal of the traces of the proteins and blood traces and all these things, and chrome was used to etch out these certain surfaces and so on and forth. So for that, with the betterment on involvement of science and technology, people have come up with the use of different chemicals which are less harmful and easily decomposed, as well as enzymes which will give me the best use or best application for the waste treatment. Another example is the iron and steel industries. So earlier, a lot of water was used for quenching. What are the large processed ingots or large processed steel is there, which needs to be brought down to the lower temperature. So people are using now the CO2 as a dry gas, or dry quenching is done. So you are getting rid of the water which is been either used or discarded in terms of steam, which was supposed to be condensed, which is difficult in the large quantities. But those things are being adopted as a dry quenching. Instead of sulfuric acid, which is considered a strong acid, HCl is used, which is considered as a relatively less strength acid or less weak acid. Direct reduction of iron instead of making into the blast furnace and all these things. In terms of textile industries, also some good practices are happening, which also involves sizing, kirking, and all other processes where the waste generated is of very toxic and very harmful and very difficult to be treated, may it be primary stage or may it be secondary stages. So starch, which is one of the complex organism, which is the starch has been traditionally used for that. The amine based or different materials are cellulosic based materials are now introduced, which has made the textile waste easy. Now all these things, as I said, technology is involved, technical and engineers were involved, they were in talk with the management peoples, and that is how good harmony for waste management has been brought and in the system. That's where process. Equipment modification, I'll just quickly give some examples of food industry and some other industries, that is a pickle industries. Now these are very small and common sense aspects basically. So if you put the screens on the drainage, so most of the food particles and ingredients which are either way you are just discarding in the drainage line, and then it is loading to your wastewater strength and concentration and volume, they can be basically taken care, and those can be discarded at the source itself. Then in the poultry industries or in the leather industries, you put the again you try to remove the feathers and other pieces of fats at the inlet stage as a source itself. As well as in the dairy industries, they have designed up some new type of cans where the cans were of the proper neck sizes, where the drainage of the water after the washing of the cans can be easily done. That drained water will contain the lot of organic fat and oil and grease ingredients. They were also collected as a part of drip pan systems were installed in most of the industries, maybe Amul industry or the Madur industries and all these things. If you happen to visit, they are adopting these waste management practices that is helping them to collect the valuable resources at the source itself, as well as bringing the less load onto the treatment level. More or less, there are certain thumb rules. What are the design aspects we discussed? Primary, secondary, tertiary treatments we have discussed. Whether depending on the COD, BOD and TDS level, they will decide. If you have that very well understanding, then you can very well talk about whether you have to go for. So there are some treatment options available, which I can put in a simplified way. That forced evaporation followed by drying option is the best one. If the COD, BOD high but TDS is low, then easily go for the biological treatment provided COD, BOD ratio is less than 3. If the COD and TDS is higher and BOD is lower, then don't go for the secondary treatment, go it directly for the incineration or the multi-effect evaporator process. If the COD is very high, that means the organic chemicals used are very high, so it cannot be easily treated by BOD, but your suspended solids are less, then in that case, go for first solvent recovery, and later on you can see today Ministry of Environment and Forestry is making mandatory for installing the solvent recovery options as a part of waste minimization concept. Likewise, there are different conditions based on the three important parameters, COD, BOD and TDS, and the suitable treatment options. You don't have to do the engineering or discovering on your own, but just consult the experts and you find the solution for the waste management basically. Then, as I said, we'll quickly look some snapshots that adoption of the treatments which were not easily accepted as a norms for the conventional plants, but they are the norms for the advanced treatment point of view. So carbon adsorption process is one of the best waste management practice, which takes care of the removal of the certain types of organic contaminants and which cannot be treated in the primary and secondary treatment. So after the secondary treatment, you take your water, treated water to this carbon adsorption process. It will take care of your volatile organic matters, remove the phenolic or refractory based chemicals and all these things, and then passing that, you can then reuse or discard into the mainstreams. Another important is a filtration. That is a treatment which is adopted for the removal of both organic and inorganic suspended solids, again which cannot be easily treated by the primary and secondary treatments. So those things can be easily taken care, and the water obtained is very well utilized, and the load on the, of course, again, what are the waste which is recovered, that can recover you the valuable ingredients if they are the mineral deposits in terms of phosphorus, nitrogen. If you then take that sludge to the tertiary treatment or multiple evaporators, you will get the valuable elemental pure phosphorus, nitrogen or other ingredients which otherwise are being just discarded, and they are the valuable fertilizer ingredients which can be easily value added to your systems and industries. This, as I already mentioned, the membrane-based technologies which further remove the dissolved solids and where the particle size is towards less than even microns or close to the atomic levels. So those sort of dissolved salts are discarded. Again, as I said, there are certain parameters. If you have to use the water made with, let's say, for the boiler applications, the TDS has to be nil. It should be zero as good as. So if you have to use your waste treated water directly in your plant, there is certain concept I'll discuss later on, that is a zero liquid discharge. So for that perspectives, these membrane technologies are playing as a wild card for most of the industries. If the industries are not using, they are supposed to use a different in the membrane-based techniques, maybe ultrafiltration, maybe reverse osmosis, but reverse osmosis is the most opted option to take care of the suspended or dissolved, very fine dissolved organic matters. Even that is utilized by the Saudi Arabia and all other kind of say nations for removal of the salt, desalination. And if you all know, Saudi Arabia is the country which doesn't have any fresh water. They rely on the saline water obtained from the seashore, that is a Dead Sea or water, the Middle East Sea, which is available in their countryside, and maximum drinkable water they obtain by doing this membrane reverse osmosis process to obtain the drinkable water. So it is considered as a end of the use pipe, but this plays a very important technique to take care of the wastewater minimization and bringing, because if you make that water as good as the pure water which you are getting from the rivers and canals basically, so you don't have to depend on the fresh water requirement. And if you are not depending on the fresh water requirement, those water will be available for other activities or for the needy people. Only what you require will be the makeup water, and that's how you can become the self-reliant as a part of waste management concept. Another is a multi-effect evaporator. These are all things I'm talking about after secondary treatment. Water is the wastewater is there. These days people are putting it to the multi-effect evaporator. Water is evaporated and then condensed. You are getting a pure water. That water you reuse in your system. And the metals or solids or valuable ingredients which are left out, generally they are identified as rich in nitrogen, phosphorus, which I already told you that they are the valuable ingredients for the fertilizer industries as a raw material, or they can be directly used into the agricultural fields. Then ultraviolet radiations, ozones to take care of the bacteria and fungi and all other aspects needs to be basically taken care. And they are your household RO systems, you will find these parts like UV radiation is there, and these are the common practices to make the waste water utilized for the regular and useful application. So this is a much important aspect, that is zero liquid discharge. And what it involves means, once you get the water in your system as a first input to your system, then you are not supposed to, or whatever the waste is generated, no waste should go from your system back to the environment or back to the atmosphere for the treatment or for discarding purpose. Everything, every single drop of water which is taken as an input should be consumed, utilized, and whatever the waste is generated should be treated, and no additional water is required. Why it is needed? There are stringent regulatory norms which are put into the system, maybe CPCB or GPCB, as well as there is a environmental need, and as well as I already mentioned, the water today we are getting as a fresh water also, it is not enough good characteristics and quality. It is increasing the load in terms of water treatment and subsequently wastewater treatment, as well as financial and economical burden. So to take care of that, this ZLD concept, no wastewater disposal, waste recovery for the utilization, as well as valley recovery and valuable salt recovery. So what you are doing by adopting ZLD is an environmental regulation compliance you are adopting. There is no cost for the wastewater disposal. You are augmenting, that means you are no more depending on the natural resources for your freshwater requirement, and you are protecting the environment. You are doing the best social service. And as I said, as a part of that, there are certain industrial norms that even Ministry of Environment and Forestry and CPCB gazettes, they are making it mandatory for the industries to adopt for the ZLD. So if you recall Dahej, we are coming up a lot of special economic zones in across the Gujarat, as well as typically in Dahej. Most of the industries are now adopting this ZLD options for their industrial plant design basically. And as I said, CPCB guidelines says that ZLD is the norm, as well as National Green Tribute. They are also emphasizing on this particular thing. This just gives that whether it's a distillery, tannery, and how you can design your ETP plant that, for example, let's say distillery biomethanation followed by reverse osmosis or multi-effect evaporator followed by incineration. Then if you take care, you are achieving a ZLD approach for your industry. Likewise, biomethanation followed by RO, multi-effect evaporator and biocomposting. Still, you are adopting it as a ZLD approach. As I said, some of these aspects were not affordable or aware. A lot of awareness needs to be done typically for the small scale and medium scale industries. Large scale industries can easily adopt certain these aspects. So likewise, these documents are available with the CPCP website for the different ZLD concepts which are to be adopted for tannery, paper and pulp, sugar industry, pharma industry, as well as textile or refineries or fertilizer, name it, any kind of industry, and we have all those industry in Gujarat. So ZLD is one of the important ingredient. I'll skip some of the slides just in the paucity of the time which is available. So these are the some important industrial advanced treatment techniques goes as a part of waste management technique. So I'll take some quick examples of case studies where some advanced techniques or some of the concepts of waste management are being brought into the practice. These are some, I'll not put much discussion, but some problem statements of pharma industry, the varying quality and market trends for the buyers, varying colors, volatile organic, inorganics, COD was very high, BOD was of 15,000 range, which are very way beyond even in terms of directly discarding the waste. You need to treat the waste within the discard limits of the COD, BOD and all these things, which was very difficult. However, marginally 1.5, so it was supposed to be treated by waste treatment, and the waste was deficient with nitrogen and phosphorus based ingredients. So they adopted the ZLD concept in their premises. I'll not get in much time to explain each and every stage, but this is a typical schematic of that particular industry which has adopted a ZLD. So these dotted arrows and dark arrow, when continuous arrows, will talk about how the interconnection of the waste streams and the wastewater streams in the plant, and they have adopted the RO systems as a part of the ZLD, and they have, I'll just show you what type of ZLD concept they are introduced which were not in their plant. That is a disc membrane desalination system they adopted. So they are taking care of the total dissolved solids, as well as followed by evaporators and crystallization systems they are installed into the system. And as a result, they are complying to the ZLD concept for their pharma industry. Another example case study is the textile effluent. So what characteristic? It is a dye with having high TDS, maybe 50,000 ppm, varying colors, as well as pH is between 4 to 5, volume is very high. So these were the different challenges adopted or faced by this industry. What waste management concepts they have adopted, I'll just take you. So what they have adopted is a new advanced technique which I have not discussed in the like carbon adsorption or filtration and all this thing, but they adopted oxidation reduction concept, and this is very interesting one. Although the COD is or the, like say the salt concentration is 50,000, by adapting this oxidation reduction process, they could able to get a very good water quality, and you cannot imagine the waste can be of that quality. I'll show you some pictures, will give you an idea. Some of these things are not to be introduced. So this is your raw effluent or raw waste. You see dark black color or brownish black color, which by doing oxidation reduction and filtration. So the second one is oxidation reduction, and the third one beaker, just see it is as good as a raw water which is flowing into the fresh water canal or fresh water river. So that sort of technical advancement we can do by adopting the logic and smart techniques into the systems. So another is another demonstration of the plant of oxidation. They have oxidation reduction treatment they have studied because they want to just establish that what type of treatment times and quantity they can do. So lab scale they have done. So within the first 15 minutes, the beaker conical flask you see here is very dark in color. By using the redox method in the beaker, you see the redox treatment is going on, and within 15 minutes, the color has changed from this black color to the light yellowish color, and after 2 hours treatment they got as good as a transparent water. So I just show another some schematics. They are implemented in the industrial scale or pilot scale as well, what we have seen as a schematics. So if you see there, the bench scale validation is done for the process, and after the 1 hour 2 hours treatment, you see the whatever the water is sprinkled is of very normal water, can be easily discarded, or if you want to reuse in the system, it can be reused. That is the beauty of applying a logic or smart approaches for the wastewater treatment and management. What I discuss about the waste strength reduction, waste volume reduction, and adopting a combination of different technologies of primary, secondary, tertiary, and those things needs to be utilized. Here is something which I showed as a schematic of where the different water activities we do at the domestic front, but there also waste minimization or wastewater management can be done. For example, make use of a newly designed water showers. So earlier, whatever you used to use 10 to 18 to 20 liter per minute showers, the new showers will reduce the half of the water flow rate, but the same effective bathing experience you will get. Then the brushing while turn off the taps. These are again a common practice, and during even the school days and child days, as well as a part of environmental science subject, we are adopting these particular things, which otherwise we used to open the tap where 6 liter per minute water was just flown, and that is a fresh water, but being we have wasted, it has gone, and that has increased the burden. It has to again pass through all the stages of wastewater treatment. That can be avoided. Flushing the toilets, use a proper design 2-button flush toilets or modules basically. So it is reducing the 2 times water which is flushed into the system. So these incremental stages on our daily activity will reduce the waste generation. These are all the waste source or the source reduction methods basically, which will reduce the loading on the effluent treatment which is produced and which needs to be basically treated on the downstream line. Then there are some certain other concepts which needs to be adopted and which we were used to adopt when where the most of the ruralization was more in prominent. But again, even the urban areas, the storm water, whatever the water we are getting through the monsoon, which basically collected and they are stored, a proper design is available and needs to be worked out. So those concepts needs to be basically adopted. Another concept is a rainwater harvesting. Again, most of the rural areas, they are having these concepts, having the deep kind of say dig wells or the big pits are made, and the water which is runoff, that is collected and it is utilized. So these concepts are more prevalent in the domestic regions, but even the industries now these days are looking to go for the particular rainwater harvesting. What best advantage what you are achieving is, because another major problem what we are facing because of urbanization is the the surface, we are making it impervious, and you are hearing and we are listening many times, if there is a flash raining is happening, the 2 feet or 6 inches or 1 feet or 2 feet depending on the demographic regions, the water is getting accumulated across the city areas. That is the reason, precisely because the land we are making the impervious for water to get percolated into the subsoil structure. Water is not getting into soil, so groundwater is not getting increased into the level, and the water storage, that is the groundwater availability, is decreasing. And many times when the monsoon region is not there, this groundwater or wherever the surface water is available, that is the major source for the rest of the year of the season basically. So by adopting this rainwater harvesting, we are encouraging that increasing the depth of the groundwaters which are generally getting depleted because of the whimsical withdrawal of the water which we are discussing in the beginning of the slides. So those things can be adopted, and that is the new concept or new strategies are being basically adopted. As a fresh students or youngsters, you need to be aware as certain norms. I have just highlighted very few and which some of us are very well aware, but there are subsections and new modifications which are keep of coming. You need to make a practice to visit the Ministry of Environment and forestry website, and what are the amendments, what are the new modifications which are coming up in terms of domestic water, freshwater utilization point of view, or the treatment of the domestic wastewater, or the treatment of new normal situations for the industrial wastewaters. As I mentioned, ZLT concepts, new concepts for the other rules and regulations. Those things will be helpful if we make an habit to visit this website. So in short, I have tried to summarize some of the aspects I have not touched up, but I'd like to make it to notice that the student should make some of those points. I'll bring it back. So wastewater management is a need of our, and some of what is to be done and what is been adopted, I have already showed you. As the fresh water is scarce and getting more and more scarce, so whatever is a water available and getting as a discarded, that needs to be brought into the recycle use concepts into the system. The water efficiency of something which I talked about in the beginning, that is a water use efficiency. Now that whimsically water, the water we are using, made be for drinking, made be for urbanization, made be for industrial activities, those things needs to be adopted by making the process change, by making the equipment modification, by making the source reduction, source modification methods, and that water what we are wasting, that can be utilized, as well as the irrigation, smart irrigation activities or things needs to be adopted by the farmers, and the farm community needs to be kind of say made aware. So if you use the water or conserve the water there, then we don't have to bother, even there are certain adverse natural situations comes in future scenarios. So adopt the cleaner production process and practices. So again, that is, as I mentioned, ministry many times keeps on coming with new notifications that needs to be adopted. Best environment management practices, when I talk about that, so I'm talking about adoption or implementation of ISO 1400 document, that is the implementation of environment management concepts, or the concepts like zero liquid discharge or life cycle analysis and energy audit, environment audit. These are the concepts I although didn't touched upon, but these are the new normals, I can say, from the industry's point of view, or the new concepts. Already I talked about the stormwater, rainwater harvesting, watershed management from the domestic front point of view. These are the important ideas, although I know this is a very vast subject with the what I just tried to focus on is a tip off on the big iceberg when you talk about the water or wastewater treatment point of view, but try to give a best in terms of, so that you, the newcomers as well as experts, also will get a idea what kind of focus we need to do. If we don't take the right step at this stage, future is going to be bleak. With that caution, I would like to summarize and stop my lecture, and thank that allowing me to take 10 more minutes for completing my talk. So I'll be happy to take the questions if are there any.
Thank you very much, sir, for presenting such a beautiful talk on wastewater management. The session is now open for participants to ask any questions. Yes, any participant having any question?
I'll stop sharing if needed, then I'll get back to specific slides so that it will be more better for me to.
Yeah, no issue, sir. Yeah. Yes, any participant having any kind of question? Yes, anyone having any queries or question? Sir, I wanted to.
Yeah.
Yes,
Go
yes.
ahead, Mahesh.
Yes, sir. I wanted to ask one question. Sir, in Arab countries, they say do filtration of the sea water and use it for use it as a drinking water. That's why it's pretty costly over there.
Yes.
Is there any time soon that we see that kind of system happening over here? Because that we can convert, say, wastewater into a drinking water and like that?
No, it is happening. That's what I said. That is the reason I talked about centralized and decentralized systems, because I gave you an example, typical like South Africa and all these things. So what is happening? Not forget about that. Even United States recently,
Hmm.
Texas and those regions, they were having plenty of rainfall. But last 2 years there was hardly any rainfall, and even the actual water what was available on the regular basis, that water was also consumed. So whatever the plenty or limited amount of water which was getting converted as a waste, they used to convert by these means of maybe membrane techniques or distillation. Distillation is nothing but your membrane based RO technique. So they adopted those techniques and made the water pure in the sense kind of say used to be treat for domestic purpose as well as bring it back to the industry purpose. Now I'll just give you a little some under idea. It looks little very fancy concept, but for example, your sewage when we talk about it is a toilet waste and all these things. But imagine there are some regions in the world, but today maybe on the tip of kind of say just maybe counted on the fingertips basically, but they are converting this toilet waste, okay, even the flush water and all these things, and making it to be used for drinking purpose. The idea again looks very fancy, pardon me for some of the listeners or viewers, but those concepts are adapting, and some of the concepts, as I said, showed from the industry also. No? You cannot easily really make out that that was such a filthy water which went through different processes and now become a fresh water. And even like New York adopts such techniques basically. We don't have to bother about India as such, because we have certain kind of say aesthetical as and cultural and perceptional views as such. But the days, as I said, the kind of water crisis, the kind of climate change we are facing, and because of certain things, what you have asked a question, probably we need to rely, and typically you may find there will be a lot of industries on the Bhavnagar coastal regions, or some of the things maybe in the Kutch region or towards the Surat side or Vapi side, you may find there are some industries going on, because if they cannot get the water which is available easily, so they are adopting those techniques for the as a desalination to get the saline water converted back for. But again, the objectives are different. You get the salt, and that salt has a certain application, so that is a different perspective. It is basically looked into.
Okay, thank you very much, sir. Any other participant having any kind of question?
The importance of ZLD in waste management.
Pardon, can you just repeat?
Sir, the importance of ZLD in waste management. It is
Yeah, as I
significant.
said, see, it is a zero liquid discharge. So, simple term. Okay, before answering, may I know what engineering background you are having?
Mechanical engineering.
Okay, very good. So generally, as that's what in the beginning I spoke, that generally these subjects are not generally we study in mechanical background. Okay, talking about ZLD, zero liquid discharge. So just imagine a particular process. You are getting 100-liter water as a fresh water, and you are using it for some activity. Let's say take kitchen activity. So we get water, we utilize it making food ingredients and food and all these things, different ingredients, and then some water we use for washing dishes that goes as a waste. Again, we consume and then we discard some water. Now, ZLD means what are the water you are taking as an intake in your system, and then it is consumed. That is consumed and it goes into the system. But what are the waste is generated? Now that no waste will be treated, and after treatment it will not go out of your periphery of your compound wall of the industry. You got my idea? So that wastewater you treat, you use the different processes as primary, secondary, tertiary, and maybe a membrane based technique, and take out all the harmful ingredients from that waste water which you treat, and make it as a useful water, and then again reuse that water in your system. So no single drop of waste you are discarding from your system. So, are you getting my point? Generally, what happens when the waste
Yes, sir.
is treated at the centralized stage, it is considered that whether the BOD is within 200 ppm level or COD is 100 ppm level and TDS is, let's say, 200 ppm, that is water acceptable to be discarded into the streams. That's what, if you see, there are different canals are there. Either the water is fed into the Narmada or Tapi, especially in the Surat and Ankleshwar regions, or if you go into the Bhavnagar side areas, it is directly discarded into the sea. So those things are discarded. What happens if your strength of this BOD, COD, which I talked about the characteristics, their concentration is high, and then you are dumping into the water or rivers, it gets diluted, and you feel that you are not harming anything, and you are not ready to take care of the or do the investment for treating the waste which you are generated on the system. But in a broader perspective, what you are doing, you are contaminating the natural sources. That's what I said. Being such attitude of the society, and the water bodies, fresh water bodies are getting more and more contaminated. The aquatic plants is getting disturbed. Aquatic life is also getting disturbed, basically. So that's the reason we are talking about. When we talk about the wastewater management, means we are talking about the sustainable development. That no, me and rest of the world nahi hona chahiye. Me and all of the world. That's the reason our cultural ethos are also like that. Vasudhaiva Kutumbakam. That's what is our ancient time, ancient scriptures. He's talking about that. You take care of everything, even a small ant and a big elephant, which consumes plenty of times food than the human beings or any other creature. So we are taking care of that type of system I'm talking about. So management, when talk about, we have to talk about a holistic approach, not a individualistic approach. So that's where ZLD is one of the concept which basically takes care of the wastewater minimization. So no water goes into the atmosphere. So I already spoke in that slide. You are complying to the Ministry of Environment and Forestry regulations. You are complying CPCB norms. You are not harming the environment. At the same time, being you are not discarding any waste. You are saving the money. What are the equipments, fresh equipments you have to purchase? You don't have to invest on those equipments. That is the concept of ZLD.
Thank you, sir.
Thank you very much, sir, for such a detailed explanation. Any other participant wanted to ask a question? Yes, anyone? Okay then, so on behalf of Mechanical Engineering Department, ADIT, I would like to thank Dr. Pravin Kodgire sir, the Associate Professor of Chemical Engineering Department, PDPU, for accepting our invitation and delivering such a detailed as well as the fundamental talk on, say, industrial wastewater management systems. So it was really beautifully presented. The topics that you have covered from fundamental to, say, detailed part, and for such a detailed explanation of all the questions as well as the topics. So we are really thankful to you, sir, and we'll also look forward to again invite you in some other program as well. Thank you very much, sir.
Welcome.
Yeah,
And if you have any
and
specific queries after your participants ask, feel free to communicate through email. I'll revert back to those queries if there are any, or any other help needed from my end. Thank you.
sure, sir. Sure, sir. Since this was the last session of our STTP, so it is my duty to present vote of thanks to the people because of whom this program became possible and successfully completed. I would like to thank the chief patron of this program and the chairman of Charutar Vidya Mandal, Shri Bhikubhai Patel sir, the honorable secretary of the Charutar Vidya Mandal, Dr. S.G. Patel sir, the vice president of Charutar Vidya Mandal, Shri Manish Bhai Patel sir, the program chair and the principal of the ADIT, Dr. Vishal Singh sir, the coordinator of this event, Dr. Mitesh Shah sir, he is also the head of Mechanical Engineering Department, ADIT. So I'll thank all these people for their support and their motivation for the smooth conductance of this program. Also, I would like to thank our participant for their active participation in this program. and I hope they've gained something through this particular program, and will also like to share that we are going to welcome you all for such other program as well. So thank you all the participants. The link for the feedback of this program will be shared through WhatsApp group or through email. So I request all the participants to fill that feedback form. Your feedbacks are really valuable to us. So thank you all the participants as well. Thank you very much. So with that, I will conclude this short-term trading program. And it's also my duty to thank Gujcoast and DST for their financial support as well. Without them, this program won't be possible. So I'd like to thank the Government of Gujarat's Department of Science and Technology. Thank you very much. Thank you, sir. Thank you.
Okay, thank you.
Thank you. Yeah.